So like today we're learning statistics, like this week 12 of this week 12 and we're learning statistics. So the first thing is the learning objectives. So after today's class, we should know how to classify types and sources of data, construct and interpret the different ways of representing data, such as histogram, bar chart, pictogram, pie chart, frequency polygon, ogive, and box plot. Then we would also know how to calculate the mean, median, mode of both grouped and ungrouped data, and also finding the mean using assumed mean. Then we also learn how to compute range, solve for range, interquartile range, semi-interquartile range, variance, and standard deviation. Then also learn how to interpret and define skewness and kurtosis. Then we solve a full JUPEB question. So like there are two types of data, qualitative and quantitative data. Quantitative data is also, qualitative data is also divided into nominal and ordinal. Nominal is just like gender, either boy or girl. Then ordinal is satisfaction, such as like it's in an order, like you have from good to fair, from poor to fair to good to like better, like that's like in order. Then we have quantitative data. There's discrete and continuous. Discrete is like you know the exact number of people. Then continuous is like when you're measuring weights, heights, and so on. So there are two sources of getting data, primary and secondary. Primary data, primary source of getting data is like first-hand experience, like going to people to ask them, interviewing people, like to get information from them. It's usually accurate, but it's also costly because and it's also stressful and time consuming. So secondary source of getting data is going online on existing sources, like online, searching for information online and other ways of getting from magazines and all that. But like it's a very quick way of getting information, but it may be outdated and you may not get the exact information you're looking for. Just like when you go online to search for something, you will see different information online. You might not get the exact information you are looking for. So these are the different statistical charts. We have histogram, bar chart, pictogram, pie chart, frequency polygon, ogive, and box plots. So like histogram and bar chart together. This is like an image. This is histogram. The bars are touching together. And then in bar charts, there are spaces. This can be vertical, this can be horizontal as well. There are spaces between the bars. And in histogram, there are no spaces, like the bars are touching each other. That is basically just the difference between histogram and bar charts. So going back, we have frequency polygon. So the first thing for you to get a frequency polygon, first of all you have the group data and the frequencies. Then with the group data, you'd calculate your midpoint. Basically, group data is like intervals. Sometimes you can have an sorry, group data you can have intervals like um I'm coming, let me try and write out. So you can have intervals like 10 to 20, 20 to 30, 40 to 50. Like these are intervals. That's like your group data. And then you'll be giving the frequency. So with your group data, you calculate the midpoint. And how to calculate midpoint is for a group data that has 10 to 20, 20 to 30, you basically add the two numbers, 10 and 20. When you add them, you would divide it by 2, and that's your midpoint. So in your table, you have the first table for class interval, that's your group data. Then the next column will have frequency. Then the next column will be midpoint. So what you would do to get your frequency polygon, you would plot the midpoint versus the frequency. So and then you join your lines. This is an example. This horizontal side is the frequency, and this vertical side is the midpoint. So we're plotting the midpoint versus the frequency. So that's for frequency polygon. That's for frequency polygon. Then the next thing we have is sorry. The next thing we have is pictogram. So pictogram is basically using pictures to identify data. So for example, these books now, this pair of three, one that's representing one. So student A has 1, 2, 3, 4, 5, 6, 7, 8, 8 books. Student B has 5 books. Student C has 10 books, I think. 1, 2, 3, 4, 5, 7, 8, 9. Yes, 10 books. So it's just basically using pictures to like represent data. So the next thing is pie chart. So for example, we are trying to like find we want to draw a pie chart of this. It says blood group A has 108 degrees, blood group B 72 degrees, blood group AB 54 degrees, blood group O 126 degrees. So first of all, you have to make sure that your degrees, everything is going to sum up to 80. 360, because 360 is the angle like of a circle. So you have to make sure this 4 degrees will sum up to 360. Then you draw your pie chart. So let me show you an example of the pie chart. So this is it. This is an example of your pie chart. Then the next stuff we have is ogive construction. So these are the intervals we are given. You put it in the table. The first column of the table is class interval. Then the next column is your frequency. Then you find your upper class boundary and your lower class boundary. So to find upper class boundary, you minus 0.5 from the first number, that's 10. So if you minus 0.5, you have 9.5. So then the next number, you add 0.5 to it. So you have 9.5 to 14.5. Then the next number 2, you minus 0.5 from 15. You have 14.5, and add 0.5 to 19. You have 19.5. The same thing, you minus 0.5 from 20. You have 19.5. You minus you add 0.5 to 24. You have 24.5. And the same thing for this last interval, you have 25 minus 0.5, that's 24.5. Then 29 plus 0.5, that's 29.5. So you are plotting for ogive construction, you plot the upper boundary versus the cumulative frequency. And to find cumulative frequency, given the frequency is 5, 14, 26, 30. To find the cumulative frequency, you have the first number, write it out as 5. Then to get the next one, it's going to be 5 plus 14, making it 19. Then the next one is going to be 19 plus 26, which is going to give you 45. Then next one is going to be 45 plus 30. That's going to be 45 plus 30. That's going to give you 75. So this is your cumulative frequency. So let me show you an example of what the Ogive construction looks like. This is just like plotting a graph, but plotting the upper class boundary versus the cumulative frequency. So this mic is on. Can you please turn off your mic? Then we have another. Sorry, please, can you turn off your mic? So we have another way of presenting data, that's box plots. So box plots is basically drawing a box of the minimum value, the the lower quartile, the median, the upper quartile, and the maximum number. So for you, the first thing you have to write out is your minimum number. From this data set we are giving here, the smallest number, that's the minimum number, is 1. So you write it out, your minimum number is 1. Then the next thing you should find is your median. So looking at this data set, the middle number, that is your median. Median is the middle number. The middle number is 7. So your median is 7. Then your maximum number is 15. That's the biggest number there. So you write it out, your max number is 15. So Q1 is the lower quartile. First, we have divided, having the median now. This our data set is divided into, that's the upper side, that's the side before the median, and the other parts after the median. So looking at the parts before the median, that's 1, 1, 2, 3, 5. You find the median of that part, and the median of that part is 2, making your lower quartile, that's Q1. Q1 is lower quartile 2. So the part after the median is 7, 8, 10, 12, and 15. And the middle number after that part is 10. So that's your upper quartile, Q3. So your upper quartile is that's the median of the upper part, and that's 10. So for you to draw your box plot, you will start from your minimum value. So let me show you an example. So here that has your max, you would write it as 10. As 15. You write it as 15. Sorry, this thing is meant to start from the minimum. I think the image is like upside down. So like the first thing I'm meant to write is your minimum. Then the next thing you write is Q1. That's, you draw a box. Then next thing you write is your Q1, and Q1 is 2. Then the median, you draw a line in the middle. Then you write your median, that's 7. Then after the median, the next thing you write is your upper quartile, that's Q3. You write it as 10. Then you draw a line. Those lines are just called whiskers. The lines connecting the box plot to the minimum and the max, they are called whiskers. Then you write your maximum value now. That's 15. That's 15 years. So remember, we're starting from the minimum value to the maximum value. So the first thing you're writing is the minimum value, then the Q1, then the median, then the Q3, then the maximum value. So this is the box. The box has the Q1, median, Q3, and then the whiskers are connecting the minimum and the maximum value. So We're done with like data representation using statistical charts. So now we'll be going to central tendency. And central tendency is just finding mean, median, mode. But then we have mean, median, mode of both grouped and ungrouped data. There are different formulas for solving grouped data, and there are also different formulas for solving ungrouped data. So mean is just the sum of all the numbers. This is for ungrouped data. So mean is just the sum of all the numbers divided by the total number. So like you have a data set of 1, 2, 3, 4, 5. For example, we have a data set of 1, 2, 3, 4, 5. The mean is basically 1 plus 2 plus 3 plus 4 plus 5. And that's 1 plus 2, 3, 3 plus 3, 6. That's 15. 15 over 5. Because the total number here is 1, 2, 3, 4, 5. That's 15 over 5. That means the mean is 3. So median is the middle value. So from these data sets I just called now 1, 2, 3, 4, 5, the median is 3 because it's the middle value. And mode is the most frequent value. So in these data sets now, there is no mode because no value repeats itself. Mode, for example, I had 1, 2, 3, 3, 3, 4, 5. The mode in this data set I called now 1, 2, 3, 3, 3, 4, 5 is 3. The mode here is 3 because it occurred 3 times. So it has the highest occurrence. So that's what mean, median, mode is for ungrouped data. So this is for grouped data. We have mean for group data is sigma f, that's summation fx, that's adding everything together. This sigma, that e symbol, is basically summation. So you have to add like all the fx together and add all the fx is just frequency times the data, like what is given. Then median is L plus n over 2 minus CF over F times C. So in this median formula, L is the lower class boundary of the median class. L is the lower class boundary of the median class. N is the total number of the data set. Then the CF there is cumulative frequency before the the median class. Then the F is the frequency of the median class. Then the C there is class width. So moving
Sorry,
on.
sorry, please excuse me.
Yes.
Sorry, I don't know if it's only me, but your screen keeps going blank, and at the moment it's blank, and like nothing is showing.
Sorry. Can you see anything now?
No, 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 nothing is showing at the moment. I don't know if it's only me or maybe it's network. I don't. Okay, I can see something now. Okay, it's showing now. It's showing now.
So can you see it now?
Yes, it's showing now.
Okay, sorry. Back to the median. I said the L in the formula is the lower class boundary. Then the N is the total number of the data set. Then CF is the cumulative frequency before the median class. Then F is the frequency of the median class. And then C is the class width. I'm just stating the formulas now. Moving forward, we'll solve questions using these formulas. So mode, the formula for mode for grouped data is L plus this is meant to be data 1 over data 1 plus data 2. So that's times class width. So data 1 is f naught minus f1, and f naught is the frequency before the modal class. Then f1 is the frequency of the modal class, and data 2 is f1 minus f2, and f1 is the frequency of the modal class, and f2 is the frequency after the modal class, and c is still your class width. Modal
Excuse
class
me
is just
now.
hmm?
Your
Yeah, I can
screen is
hear
not
you.
clear.
Sorry, is
Your
it the
screen
same thing for others or just you? If you're experiencing the same problem, can you speak up?
is showing now.
I'm
I
seeing it
think
clearly.
the problem is from you or maybe your network.
Alright, alright.
Can you see it now?
Yes, it's showing now.
Okay, so data 1 is f naught minus f1, and data 2 is f1 minus f2. So quartile and semi-interquartile range. So this stuff fitting QK is, it can be Q1, it can be Q2, it can be, that's K is just showing the number there. It can be Q1, it can be Q2, it can be Q3, it can be Q4, it can be Q5. So if you want to find the code, let me say we're looking for Q2, you have L, that's still the lower class boundary of that class, and plus, then now you multiply. K is the number. For instance, you are looking for Q3 or Q2. You will do 2 times the total number over 4. So as we all know, quartile is quarter and quarter is 4. So we'll divide the n by 4. This is just the same formula as the median formula, but in this scenario, we're looking for quartile, so we're dividing by 4 instead of 2, and would multiply the total number by the constant there. It can be Q1, it can be Q2, Q3, Q4, Q5, and so on. So we're just going to multiply the number with the constant number times the total number of data sets over 4. Then minus, this is cumulative frequency before that class. And for you to find the quarter, we are looking for second quartile, that's Q2. To find the class that bears the second quartile, you would just do Kn over 4. So Kn over 4, that is going to be 2 times. For instance, you have the data set of 10. So it's going to be 2 times 10 over 4. That's 20 over 4. That's 5. So you find the class that has 5 as its cumulative frequency, and that's your your second quartile class. So to find semi-interquartile range is basically Q3. You first of all find your Q3 using this formula above, and find Q1 using the same formula above. Then you minus Q3 minus Q1, all divided by 2. And that's how to find your semi-interquartile range. Then measures of dispersion. We have range. Range is maximum number over minus minimum number. That's the biggest number there minus the minimum number. Then we have the interquartile range. That's Q3 minus Q1. Then we have variance. And variance is summation x minus mean all square all over n. Then standard deviation is just the square root of variance. So after finding your variance and you want to find your standard deviation, you just square root your answer. So we have this is like another way of representing data. Sorry, not representing data, of analyzing data. There's skewness and kurtosis. So when you draw a graph, let me use the example to show you. Sorry, I'm coming. So this is an example. The first one is saying positive because, as you can see, it's leaning towards the left. It's leaning towards the left. So, hey. Sorry. The first one is positive. When your graph, you plot a graph like this and it's leaning towards the right, it's positive. And when it's leaning towards the left, it's negative. So what it basically means, like, if you solve a question and they tell you to determine the skewness or the skewness of the question you just finished solving. If your mean, you've solved for your mean and you've solved for your median. If your median is less than the mean, that's if the mean is greater than the median, it's positively skewed. And if your mean is less than the median, it's negatively skewed. Then kurtosis is just showing how the graph is. As you can see, this first one that is flat is platychotic. That's it's flat. Then the next one is slightly peaked. That's mesocotic. And then the last one that is like very peaked is leptocotic. It's just used in analyzing this data. Like after plotting your graph, it's used in analyzing the graph. So this so far, is there any question? Sorry, can you hear me? So far, is there any question or I should move on? Is there any question or should I move on?
You can move on. There's no question.
Okay. So this is an example. This is like a full example where we would be finding the mean, median, mode, interquartile range. Like we'll just be solving everything we've done so far. So the question, we're giving the class interval and the frequency. So you draw your table. That's the first thing you are going to do, is to draw a table. So the first thing you write is 10 to 19. You repeat the table they've already given you. 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. And the frequency given is 4, 6, 10, 8, 12, 7, and 3. And they've told us the total number, that's n. Total number, that's n, is 50. So the next thing you do is to find your midpoint. And the midpoint is x. So to find your midpoint is basically adding 10 plus 19. Then you divide it by 2. 10 plus 19 divided by 2 is going to give you 14.5. 20 plus 29. When you divide it by 2, you are going to get 24.5. 30 plus 39, you get 34.5. I remember your class interval is 10. You are seeing the interval between these midpoint 14 plus 10 is 14.5 plus 10 is 24.5. 24.5 plus 10 is 34.5. So that's a trend there, following your class your class width, that's 10. So you have 44.5, 54.5, 64.5, 74.5. So the next thing you draw in your table is fx. That's multiplying the frequency and the midpoint. And why we're doing this is so we can be able to calculate our mean. So fx is 4 times 14.5, that's 58. 6 times 24.5, that's 147. 10 times 34.5, that's 345. 8 times 44.5, that's 356. 12 times 54.5, that's 654. 7 times 64.5, that's 451.5. 3 times 74.5 is 223.5. So you add your fx. Sorry. You add your fx, everything. You add everything. So under the fx, you write summation fx, that's efx, equal to the sum of everything there is going to give you 2,235. So under your fx, you just write summation fx, that's that fx is equal to 2,235. So we'll calculate your mean. So mean is, remember the formula of I told you earlier. So mean is like represented as bar x. That's x bar, x with a small dash on top. That's what we use in representing mean. So mean is total fx, that's summation fx divided by summation f. And summation f is the total number. That if you add this frequency, everything is going to give you 50, and that's your summation f. So mean is 2,235 divided by 50. Then your mean is 44.7. So the next thing we're going to calculate now is the median. So I told him our total frequency, that's n. Total frequency, that's n, is equal to 50. So for you to find your median class, you do n over 20. N over 20. So n over 2, that's 50 divided by 2, 25. Can you- So we've gotten n divided by 20 by 2 is 25. So we'll get our median class using this. So to find the median class, we'll draw in another table. We'll draw another table, and then that table, the heading is going to be cumulative frequency. So to find your cumulative frequency, you go back to your frequency, the column of frequency, write out the first number there, 4. To find the next row, that's 4 plus 6. You write it out. Next one is 10. So write out the next one is going to be 6 plus 10. That's 16. Then next one is 16 plus 8. That's going to be 24. All right? Yes, 24. Then next one is going to be 24. Sorry, is it 24? 25. Okay, 24. Then the next thing we're going to have is 12. 24 plus 12, that's 36. Then plus 37 plus So I think I'm making a mistake somewhere. And so yeah, our cumulative frequency table is 4, 10, then 20, then 28, then 40, then 47, then 50. So we have already found out that n divided by 2, that's 50 divided by 2 is 25. So to get the median class, you go to your cumulative frequency table and you find out the number that 25 falls into. And the number that 25 falls into is this 28. So that means your median class is 40 to 49. You like 25, that's after dividing n divided by 2, that's 50 divided by 2, we got 25. So we'll find out where that 25 falls inside in the cumulative frequency, and that's in between 28. So your median class is 40 to 49. So the next thing you would do now is to go to your median formula. Then you find the lower class boundary. That's L. Lower class boundary is the lower class boundary of the median class. I remember I said to find lower class boundary is the number in front minus 0.5. So when you do 40 minus 0.5, you have 39.5. Then we already found that n over 2 is 25. So we have 39.5 plus bracket 25 minus we're going to use the cumulative frequency before the median class, and the cumulative frequency before the median class is 20. As you can see, this is 28, this is 28, and the cumulative frequency before 28 is 20. It's 20, so we're going to use 20 there. Then the next thing now we're going to find is the frequency. We're going to use the frequency of that class. The frequency of that class is 8. The frequency of class 40 to 49 is 8. Then the class interval is 10. So we'll put it in our formula and solve it out. That's 39.5 plus 25 minus 20 divided by 8, all in bracket 10 times 10. So remember, we'll solve the bracket out first. So that's 25 minus 20, that's 5. Then 5 divided by 8. Then that's 5 divided by 8 times 10. Then we now add. So your median is 45.75. The next one is 1 plus data 2. Please, that is not D1, but it's data 1. That's like a triangle. Data 1, that's changing 1 and change 2 times C. So the modal class is just the class that occurs the most. So using the frequency to check, the class that occurs the most is 50 to 59 because it has a frequency of 12, which is higher than every other frequency there. So the modal class is 50 to 59. Remember, to find the median class, we did n divided by 2. Then to find the modal class is the class that occurs the most. So we have found our modal class to be 50 to 59. So F1 is the frequency. F1 is the frequency of the modal class. That's 12. The frequency of the modal class, that's 12. Then the frequency before the modal class, that's F naught, that's F0. F naught is 8. Then the frequency after the modal class, that's F2, is 7. So we'll put it back in our formula. First of all, we find what data 1 is, and data 1 is F0 minus F1. Sorry, data 1 is F0 minus F1. So you can put this in a modulus, that's like 2 straight lines. So you have 2 straight lines here. So you have 12. Sorry, it's meant to be 8 minus 12. So these straight lines we're putting it in now is to like counter the minus sign. So when you do 8 minus 12, you have a minus 4 in this. So this modulus sign we put now is going to make it 4. Do you understand? The modulus sign is to remove the minus, because our formula, this is wrong. It's meant to be 8 minus 12. And then you have a minus 4 as your answer. But this modulus sign, these straight bar lines we put it in, is going to counter the minus, and then it's going to bring out your answer as 4. So data 2 is 12 minus 7. There's no minus, so the modulus sign is not necessary. So that's 5. So you put it back. Sorry, any question? Any question? Okay, so your mode formula, your L is still the lower class boundary of the modal class, and the modal class is 50 to 59. So lower class boundary is 49.5. That's 50 minus 0.5. So that's 49.5 plus your data 1 is 4, bracket 4, over, that's divided by 4 plus 5 times 10. So like when you work it out, you work the bracket first. So you do 4 plus 5 first, that's 9. Then 4 divided by 9. Then multiply your answer by 10 before you add it to 49.5. You have to follow this procedure. You first work the bracket first, the inner bracket first, that's the under. Then you now divide it before you multiply it to 10, before you add it to your lower class boundary. So your mode here is 53.94. So if you wanted to determine the skewness, whether it's positive or negative, remember I told you if the mean is greater than the median, it's positive. If the mean is less than the median, it's negative. So here we have a mean of 44.7 and a median of 45.75. So here the mean is smaller than the median. So this is negatively skewed. This our solution is negatively skewed. Sorry, can you turn off your mic if you don't have a question? Please, can you turn off your mic if you don't have a question? If you do, just put it turn on your mic and ask your question. So we found the mean, we found the median, and we found the mode. So now we want to find the quartile. That's first quartile. That quartile 1 is also the same thing as lower quartile. I also want to find quartile 3, which is the same thing as upper quartile. So I told you that finding quartile is just sorry, excuse me, is the same formula as your median formula, but then we're going to divide by 4, not 2. Because remember, middle, like we're dividing a data set into 2. But then quartile, we're dividing it into 4. So we're dividing by 4, not 2. So first of all, we'll find the Q1's class. And to find the Q1's class, like the way we did in the median, Remember, in the median, we did n over 2. Here, we're going to do n over 4. And remember, n is 50. So 50 over 4 is 12.5. So you find the class. So Q1's class is in between 20. The 12.5 is here, so the class is 30 to 39. That's the class of the Q1. So the next thing we'll find is the lower class boundary. Remember, I said the lower class boundary is this first number minus 0.5. So we have 30 minus 0.5. 30 minus 0.5, and that's going to give you 29.5. Sorry, that's a mistake. That's going to be 29.5. So we'll go back to our solution. I'm coming. Let me just clear this. So we found out that the quartile class, that the first quartile's class is 30 to 39. So the lower class boundary is 30 minus 0.5. That's 29.5. Then the cumulative frequency before that class is 10. The cumulative frequency before 20 is 10. So the cumulative frequency is 10. Then the frequency of that class is 10. See, the frequency of 30 to 39 is 10. Then Q1, Q1's formula is L plus N over 4. That's 12.5 minus the cumulative frequency before, that's 10, divided by the frequency of that class, that's 10 as well. Then the class width is 10. So you solve out, that's 29.5 plus, work out the bracket first. So you have 2.5. When you are done solving out, you add it, you have 32 as your answer. So that's for the first quartile. So to find the third quartile, that's quartile 3, the same thing as upper quartile, using the same median formula. But I told you is for the quartile, you have Kn. So the first quartile is 1. So Kn is 1. 1 times n, that's still n. So now we have Q3 and we have Kn, that's the constant here is 3. So it will be 3 times n. So you find the Q3's class first of all. Sorry, whose mic is on? Please, can you turn it off? So you have 3 times 50 divided by 4. And that's going to be 150 over 4. And then when you divide out, you have 37.5. So you find the class, the class that has a cumulative frequency where 37.5 falls into, and that's 40. So your Q3's class is between 50 to 59. So your Q3's class is 50 to 59. So you find your lower class boundary. Sorry, you find your lower class boundary. And your lower class boundary is 50 minus 0.5. That's 49.5. Then the cumulative frequency before 50 to 59 is 28. So your CF is 28. Then your F is the frequency of that class, and the frequency of that class is 12. So you put it back in your formula. You have 49.5 plus 3n over 4, which already give us 37.5. So bracket 37.5 minus your cumulative frequency before the class, which is 28. Then divided by the frequency of that class, which is 12. Then times the class width, which is 10. So we've gotten 49.5 plus, you work out the brackets. When you work it out, you have 79.2. Then when you add it to the lower class boundary, your answer is 57.42. So that's for your upper quartile, which is the same thing as quartile 3. So now we have found your quartile 1, which is lower quartile, and quartile 3, which is upper quartile. So the next thing we'll find is your interquartile range and semi-interquartile range and your range. So range is basically the minimum number minus the maximum number, which is the smallest. Sorry, this is a mistake. Range is the maximum number minus the minimum number, which is the largest number minus the smallest number. So the largest number here in groups data, the largest number is this last number here. The largest number is this last number here, and the smallest number is this first number. So if you want to find your range, it's going to be 79 minus 10, making your range 69. So you just pick out the last number in the data set minus the first number. So that's your range. So interquartile range is just the upper quartile, that's Q3, minus the lower quartile. And we already found our Q3 as 57.42, and we found our Q1 as 32.0. So you do 57.42 minus 32.0, that's 25.42. So the next thing now we would find is the interquartile range. An interquartile range is Q3 minus Q1 over 2. And here we already found that Q3 minus Q1 is 25.42. So you just did 25.42 divided by 2. And that gave us 12.71. So that is how to find your interquartile range, semi-interquartile range, and range. So we're trying to find variance now. So to find variance, first of all, we write our x. X we already got was the midpoint. Remember how to get your midpoint from your class interval. You add both of them and divide by 2. So you have your midpoint, which is x. Then the frequency, which is f, was already given to us. So then next thing we'll find is the deviation from the mean. So deviation of the mean from the mean is x minus the mean. And we have x as the midpoint here minus the mean we've gotten before, and our mean was 44.7. So what we're going to do now is x minus mean. So the first thing we did is 14.5 minus 44.7. That gave us minus 30.2. Then the next thing we did is 24.5 minus 44.7. That's minus 20.2. Then 34.5 minus 44.7, that's minus 10.2. Then 44.5 minus 44.7 is minus 0.2. Then 54.5 minus 44.7 is 9.8. 64.5 minus 44.7, that's 19.8. Then last one is 74.5 minus 44.7, that's 29.8. So the next thing now we're going to find is the square of this deviation. Like this thing we just got now, we'll find the square of it. This 30.2 20 minus 20.2 minus 10.2 minus 0.2 9.8 19.8 29.8. We'll find the square of it. So to find the square, we'll do 30 minus 30.2 square. Is going to give you 912.04. Remember, there are two minus here, so minus times minus, that's plus. So we don't repeat the minus here when we square. So 20 minus 20.2 square will give us this, minus 10.2 square will give us this, minus 0.2 square will give us this, 9.8 square will give us this, 19.8 square will give us this, 29.8 square will give us 808.04. So the next thing we're going to find is f times this deviation square. You can name this your x minus mean d. So you next thing you have is f, your column you have f, x, f, then d square, then f d square. Or you can just leave it like this as f bracket x minus mean square. So we're going to do f sorry f times this to get this. So we're going to do 4 times 912.04 to get this. We get 6 times 408.04 to get this. 10 and so on. We multiply the frequency. 10 times 104.04 to get 1040 1040.40. 0. We'll do 8 times 0.04 to have 0.32 and so on. Same thing, we'll do 3 times 888.04, we'll get this. So then next thing we have is summation this. That's we'll add everything. Summation basically means adding all this. When you add all this together, you have this. So we just add everything here to get this. This summation f d squared. That's summation f times x minus mean square. So we added everything we got here now to get this. So remember I told you the formula for variance is summation f bracket x minus mean square over summation f. That's the same thing as n. Summation f is just the sum of this frequency. Sum of this frequency will give you the total number. So the sum of this will still give you 50. And we already know the total number is 50. So you just do your answer from this summation f bracket x minus mean square divided by the total number. That's summation f or n. You can call it whatever. So you have your variance as this divided by this, and your answer is 253.96. And I say standard deviation is basically the square root of variance. Standard deviation is just the square root of variance. So we've gotten your variance as 253.96. So standard deviation is square root of 253.96, which will give you 15.92. So this is just a roundup of all the answers we've gotten. If there's any question, is there any question? Hello, can you hear me? Is there any question?
No, no question.
So just a like round. If there's no question, I think we're done. Okay, let me explain using assumed mean. In some situations, you are given an assumed mean. Sorry, let's go back to mean. In some questions, you are given an assumed mean, and the formula for finding mean, this is mean using assumed mean, is a plus sigma fd over sigma f. So like sometimes we're given an assumed mean, which is a, and we're asked to find the mean. Maybe the question say using assumed mean a is equal to 30. For instance, they gave it a as 30 and they told you to find the mean. So we'll have summation fd. Summation fd is just the same thing as here. I'm coming. I told you that your x minus mean is the same thing as d. So for you to find your assumed mean, I told you your x minus mean is the same thing as d. sorry, D. So you can have this as D square. You can have this as FD. Sorry, you can have this as D square. You can have this as FD square. So for you to find your assumed mean, your mean using assumed mean. So you have another table. You don't need all this table. You just have another table of FD. So you just have 4 times 30, have a table and put 4 times minus 30, 6 times minus 20.2, 10 times this, 8 times this. Like have another table and name it FD. And then you just do the math of multiplying 4 times this times this, and that's how you have your this column of FD. So when you are done, you add up everything you've gotten. That's your summation F. Sorry. That's your summation FD. That after multiplying out and you add everything, you have summation FD. So going back to your mean formula using assumed mean, we've gotten summation FD. Then remember I said summation F is the same thing as N, and summation F is 50. So you have 30 plus, sorry, you have 30 plus, for instance, after adding everything, we had 20. We had 20. So your mean, that's X, is going to be 30 plus 20 over 50. So or 20, for instance, that's 30 plus 20 over, let me say you had 200 after adding, sorry, for instance you had 200 after adding, so you have this to cancel out, 5 divided by this, you have 4. So you have 30 plus 4 is your mean now will be 34. Do you understand? Sometimes you can be asked to find your mean given an assumed mean. So this is the method. This is the method of finding mean using an assumed mean. You'll be given A, then you have a table and find what FD is. D is X minus mean. So in this situation, we'll be doing X minus assumed mean. So it's the same thing as X minus A. Remember, I told you we are given an assumed mean of 30. So for you to find this, you have X minus mean, that's X minus A in this situation, because we don't know what the mean is. So we're going to use as our assumed mean, that's X minus 30. Do you understand? Do you understand? So like these are just like few exam tips for like your JUPEB. Make sure if you are asked to label a chart, make sure you're labeling your chart clearly. For a histogram, if you want to label like the histogram, remember the frequency is down and like what you are plotting it against is this. For instance, you are plotting score against frequency. When you say something against or score versus frequency, the first one, which is score, is going to be on the vertical axis, then the frequency is on the horizontal axis. So remember, if you are plotting, write it out at the end what its frequency. Like after these numbers now, you write at the end after 16. I'm coming. After 16 here, you write frequency. Then here, up here, you write blood group. Just label it write it out so like the person looking at it doesn't have to like crack their brains to like understand what you're plotting against. So once they just see you wrote blood group up here, they know that, oh, this line is for blood group and this horizontal line is for frequency. The same thing goes for your histogram. Your this is for bar chart. This bar chart can also be like this. It doesn't matter where it's facing. Your bar chart can also be like this. And then here is your blood group and here will be the frequency, because the numbers will now be here as 8, 6 or anything 4. And here you have a sorry, you can write your AB, your blood group or anything you're plotting against. So it doesn't matter whether it's horizontal or vertical, it's still the same thing. Then your pie chart, like when drawing your pie chart, make sure that all your angles sum up to 360. Like from our question, we had from our question we had 0, 108, 72, 54, 126. So here is going to be, looking at this angle, we know that this biggest one is going to be 126. Don't make assumptions, try to measure your angles. And here is going to be 108. MC1 here is 108, then here is 72, then here is 54. So we're going to make sure that this, when you sum up everything here, you have 360, because 360 is angle at a point. So like everything here should make sure it's up to 360. For instance, now you had here as 125. It's wrong because you have your total angle as 359, and that's not summing up to angle as a point. So you have to make sure that everything is going to sum up to 360. Then make sure you're showing all your workings. Make sure you're stating your formula, and when you state your formula, make sure you write, okay, when you are solving for your mean, median, mode for group data, make sure you show all your workings. For instance, you're showing yes, using L plus N over 2 minus CF over F times C. You write it out. Your L is lower class boundary, and your lower class boundary is this. This is the median class. Write it out. Write your cumulative frequency. This is cumulative frequency before the that you write CF. Oh, CF is the cumulative frequency before the modal class, because people have different ways of representing it. Some people represent their cumulative frequency with big letter F and represent the frequency with small letter f. So you have to tell whoever that is marking your script that, oh, this CF I wrote here is to show cumulative frequency before the modal class. Then you proceed to write what the cumulative frequency is. Then also practice questions. Keep practicing questions. Don't assume you know it. Just keep practicing questions. If there's no question, I think we're done for the day.